Hello, let us look at some volume questions together. The first question here it is, the region in the first quadrant bounded by this function over here, and then x equals pi over 4, and it is rotated about the x-axis. What is the volume of the solid? Okay, so if you were to uh, sketch it a little bit to see what's going on, since the graph of the secant x is the reciprocal of cosine, so you would have gone something like this, where the vertical asymptote is pi over 4 and pi over 2. So pi over 4 would have been somewhere a bit before that. Now it has been rotated about the x-axis in this way. Then we are looking at this area. So how do you find the volume? So what we're going to be doing is this. We will be looking at this one using the disk method. Okay, the purple line would have been the radius. Then our volume would have been equal to pi r squared, but r is equal to y value, which is secant square x dx, which goes from 0 through pi over 4. Then let us try to calculate this one. Pi stays as pi. What is the antiderivative of secant square? It will be tangent x, which goes from 0 through pi over 4. Now, so when I plug in pi over 4, then I get tangent of pi over 4 minus tangent of 0. But we know that tangent of 0 is 0. Tangent of pi over 4 is equal to 1, so this becomes simply pi, which is choice C. Let us look at number 2 here. The region in the first quadrant between the x-axis and the graph that's given here. So I'm going to try to sketch it first a little bit to help us understand a bit better. And if I have something, it would have been something like this, I guess. Looks like a parabola. Alright, so this must be equal to 6. This must be passing through the origin. Now, this area has been rotated about the y-axis. Now, then how can we figure out the volume? In fact, imagine this is the uh, shell that would be going around this way. So that means we're going to be using the shell method. Then volume becomes 2 pi. R here becomes the distance from y-axis to that particular point. We call that as x. And h is the y value here. Y value is 6x minus x squared dx, which goes from 0 through 6. So this becomes our answer. So I'm looking for anything that has this one. It looks like choice B becomes our answer. Alright, let us move on to number 3. If the base of a solid is region enclosed by this graph, so once again, and then the graph would have looked something because of the negative. Instead of going up, it's going to come down actually. And it's going to continue, of course. Now, and line x equals 3. So let us say this is equal to x equals 3. If the whole plane cross-sections perpendicular to the x-axis are squares. So in other words, if I have a square, I try to draw the picture, squares, then its volume is. So how do we find the volume in this case? V is equal to integral of the area in this case would have been side squared. So side is the y value. So we get e to the negative x squared dx, which goes from 0 to 3. Now then this is equal to 0 to 3 for e to the negative 2x dx. So when you take the integral of e to the negative 2x, then we get e to the negative 2x. But by the chain rule, we have to divide by negative 2, which goes from 0 to 3. So if you have to plug in 3, then we get negative e to the negative 6 over 2. I just brought the negative sign to the front. Now minus, if I have to plug in 0, then we get negative from this bottom over 2. Top portion becomes e to the 0 power. Now, the negative becomes positive, and e to the 0 is equal to 1, so what we end up getting is negative e to the negative 6 plus 1 all over 2 because they have the same denominator. Then this looks like choice A becomes our answer. Alright, let us move on to the next question, number 4. The base of the solid is enclosed by the parabola here, as we can see. And then the line x equals 1. So then, once again, to help our understanding a bit better, in the first quadrant, and I'm going to assume that the y equals 4x squared, and x equals 1. So let us say that's equal to 1. Now, in each plane section of the solid perpendicular to the x-axis is square. So once again, I can imagine a square. The volume of the solid. So how would you find it? The volume is equal to, which goes from 0 to 1. In this case, the length of the side is a y value, which is 4x squared. Entire thing squared to find the area of the square, because side square is the area, and dx. Here then what do we end up getting? From 0 to 1, so we have 16 x to the 4th power dx. Then when you integrate this one, we get 16 over 5 x to the 5th power goes from 0 to 1. When you plug in 1, we get 16 over 5. When you plug in 0, we get 0. So our answer is simply 16 over 5, which is choice V becomes our answer. Number 5. The region R is the first quadrant enclosed by x equals 0, y equals 5. So let us try to plot that first. X equals 0 in this case is the y-axis, and the y equals 5 would have been somewhere around here, let us assume. And then the graph of y equals x squared plus 1. So then it would have been going up this way. Of course, we have this left side, but I just erased that because we're only looking at this quadrant right over here in the first quadrant. Now, then this has been revolving around the y-axis. Okay, then what will happen? We can use the different kind of methods, but since the function is in terms of y, we can use the shell method that goes up and down. This will be the height, and this will be the radius. Then we get volume is equal to 2 pi. R radius is equal to x, and then h is equal to this one minus 1. So we get x squared plus 1. Actually, I have to do it the other way. Upper one is y equals 5. So 5 minus x squared plus 1. So 2 pi r h, that's basically what we have done, dx, which goes from 0 through. Now we need to figure out this point. If you set that equal to 5, you will realize that x must be equal to positive or negative 2. So we know that this one to be equal to 2. So I'm going to put the upper boundary as 2. Now, then let us try to look at this one more time. So we get 2 pi from 0 to the 2. So we have x times 5 becomes 5x, but we have to subtract 1 here, so we get 4x. And then second one is minus x cubed dx. If you calculate this one further, we get 2 pi, and then 4x becomes 2x squared minus x to the 4th power over 4, where it goes from 0 to the 2. So when you plug in 2, then we get 2 pi times here we get 8 minus 2 to the 4th power becomes 16 over 4 becomes 4. When I plug in 0, both of them happen to be equal to 0, so we end up getting 8 pi becomes our answer, which is choice B. Number 6. Let R be the region between this one and then this one. So then let's try to sketch the function one more time. And I'm going to assume that y equals 1 is way on top, just to exaggerate a little bit. Y equals sine of x would look something like, and then continues on. And this section is revolving around the x-axis. Since it's revolving around the axis and use the kind of hole in the middle, what we can do is we can do the washer method. So then the volume becomes pi, and then first one is the outer radius, which in this case would have been this value, which is equal to 1. So 1 square minus inner radius, which is this one, sine square x, and then dx, which goes from 0 to pi over 2. Now, then I'm just looking for something that has this component to it, which will be choice. See, this one is not correct because square is outside, where in fact I should have square only on sine square, which seems to be choice E becomes the answer. All right, let's move on to number 7. What is the volume of the solid generated by rotating about the x-axis? So once again, here we have I'm gonna draw the symbol. Now x equals 0 is the y-axis. Y equals 0, that's the x-axis. And x equals pi over 3, it would be another vertical line. Now, secant of x starts from 1, and then it goes up, pass through, and you will have the vertical asymptote when x equals pi over 2. So we're not there yet. So this can be the good area which we can look at. Now, this is rotating about the x-axis. So we can do this method once again. Then what do we end up getting? 0 through pi over 3, where the volume becomes pi r. R is equal to secant square x dx. Then we'll end up getting pi was coefficient, and then integral of secant square would have been tangent of x, which goes from 0 to pi over 3. Then we have pi, and then here tangent of pi over 3 minus tangent of 0. Tangent of 0 is equal to 0, so we don't have to worry about that. Tangent of pi over 3 becomes radical 3, so we get pi times radical 3. So anything that has this one will be our answer, which is choice C. All right, let us look at number 8 here together. If the shaded region is rotated about the x-axis, y-axis. To form the solid whose volume is 10 cubic meter. They already gave us the volume of the solid of the following, which is the best approximates K. Then, since it's rotating about this way, what we can do is we can use the shell method, given that this is the H and this is equal to R. Now, according to the shell method, volume is equal to 2 pi, which goes from 0 through K. R becomes the X, and then H becomes the height, which is equal to Kx minus X squared. And then, well, we know that has to be equal to 10. Let's try to calculate this one further. Here we get 2 pi from 0 through K. When I distribute the X, then we will end up getting Kx squared minus X cubed dx. Of course, this is equal to 2 pi. And then here we get kx to the 3 power divided by 3 minus x to the 4th power divided by 4, which goes from 0 through k. Now, when you plug in 0, we know that everything cancels out, but when you plug in k, we'll end up getting something like this. 2 pi was already there. Here we have k to the 4th power over 3 minus k to the 4th power over 4. That has to be equal to 10. Then we can see that 2 pi, and this becomes k to the 4th over 12 equals 10. So when I cancel these two things out, we get 6. So, in other words, k to the 4th power is equal to 60 over pi. Since this is a calculated question, all I have to do is 60 divided by pi, close that up to the 1/4 power. That would be the opposite of 4th power. And 2.09. So we get choice B becomes the answer. All right, let us look at number 9 here. So we have two graphs revolving around the x-axis. So once again, and here we have, that will be something like this. That would be the sketch. Y equals x, and y equals 4x minus x squared. And then this area is revolving around the y-axis. Then obviously we can do the shell method if we wanted to. Then what do we end up getting? Volume becomes 2 pi. Here, r becomes the x value. And then h becomes the upper function minus lower function, which becomes 4x minus x squared minus x dx. All right, so then here, since the boundaries are 0 through 3, then what do we end up getting? So if you have to plug in 0 and 3, I believe that's where they will be meeting up. Now, then here we have 4x minus x becomes 3x. So I'm looking for something that is equivalent to this expression, and I believe that is in fact choice E. E becomes the answer. All right, let's look at the next question, number 10. We have this figure. All right, now it is a cross-section perpendicular. This has the semicircle. How can I get the semicircle? That means I can imagine this is a semicircle right over here. That means this portion is the diameter, not the radius. So in order for us to get the radius r is equal to y over 2, and then to get the area of the semicircle, area must be pi y over 2 r squared, but that's the whole circle, so we have to divide that by 2, which means pi y squared over 8 is the area of the each semicircle. Now, then let's try to calculate this one. Here we get pi, or in fact, area becomes pi because I'm just taking this one off. Y, what's the y value? Y value in this case is equal to 8 minus x divided the whole thing by 2. So we get 8 minus x divided by 2 squared. So that's pi r squared. But we have 1/8. So I'm going to divide this whole thing by 8, which goes now from 0 through 8 dx. Now, since this is a calculator question, what I'm going to do is I'm going to put this one into calculator and see what happens. So here we have pi over 8, and then we're gonna integral number 9. So that's basically what we're gonna. Lower bound is 0, upper bound is 8, and then the expression inside here becomes 8 minus x divided by 2 I guess I have to put another parentheses here. Second insert. And then we're going to square that. That's basically what we have done. And then we are taking the derivative against x. So there it goes. All right, this one looks like 16.755. So choice C becomes our answer. All right, so then let's move on to the next question, number 11. So base of the solid is the region in the first quadrant. Very similar questions to the previous ones here. Y equals 2 minus x squared, and then so then if I were to sketch this one for a second, first quadrant, and then here we get some sort of parabola. And so if I were to assume that this is y equals 2 minus x squared. Now, cross-section solid is perpendicular to y-axis is square. So that means, in fact, we're going to get a square that looks like this. I'm drawing the parallelogram looking thing, but I'm trying to put the 3D image here. So that's why it looks something like this. Now, then in this case, what is the volume? Then volume becomes side. What is the side? This is x. So we're looking for x squared. But what is x squared? X squared in this case, we can see that is equal to 2 minus y. So we get 2 minus y. That's the x squared, and then dy, which goes from 0 through as high as 2. So that's basically what we end up getting. Then, which one is the answer? It seems like choice B becomes the answer. All right, then we'll stop here for now, and I'll see you later. Bye-bye.